Hello and welcome back. In this segment we're going to talk about arrays in Java, and we'll try and stick to one-dimensional arrays in here, and then in the next segment we'll look at the more advanced arrays concepts. So first of all, let's try to motivate the need for having arrays. So up until now all of our variables are individually declared items that have some data type. Now suppose we wanted to calculate something with all of your test grades, maybe the average of your grades. What we have now, I would have to declare a different variable for each of the grades. And if I have 100 students, that would be a ridiculous solution. So what we need is a way in Java to store lots of values in one variable. So here's a more likely picture of what we would want. We want all of the grades in one array, and it has one name. So let's look at syntax in Java for declaring such an array. So I want you to think of this as the new data type. So we have int array, and we're using the square brackets to indicate that this variable grades is not an int, but it's going to be an array of ints. You can't put anything inside the square brackets. It just is kind of the data type int array. So we don't have an array yet. We have a reference to an array, and when we allocate the space for an array, we're going to say new and then name the data type of each element and then say how many we want. So this piece of memory down here with the 10 elements gets allocated by saying new int 10. So each element in the array is an int variable, and we need a way to distinguish between the first one and the second one. So we use a subscript or an index into the array. So grades sub 0 gets 75, means a 75 goes in this spot. So each of these elements can be used as if they were any other int variable. So grades sub 0 is an int variable. It's that one there. Plus 15 means that a 90 will be going into grades sub 1. So we have as many int variables as we want in the array, as many as we need to allocate. Okay, so array elements are initialized at the time the memory is allocated. So when you say new int, all of those elements get initialized, and if it's an int array, they're initialized as 0. If you know the data that you want to put in the array, you can allocate the space for the array and fill up the array using this syntax. So remember that this declares the variable, which is a reference to the array, and now using the braces and filling in what we want inside the array, this also allocates the array of 10 elements and puts these values into that allocated space. So there's a few restrictions on arrays. The size of an array can't be changed after it's been allocated. So at the time you say new int or new whatever the data type is, you get an array of the size you specify, and you can't change that. You could make a new one that's a different size, but you can't change the one you've allocated. The size of the array must be a positive int or promotable to int. That kind of makes sense. You couldn't allocate a negative amount of space, and you couldn't allocate 2.5 spaces. So it has to be a whole number and a positive number. The size of the array might be a variable. So that means that in Java you can select the size of the array at runtime. You could calculate how much space you need and then allocate that much space. And when you're accessing the array, the index for accessing the elements must also be a positive integer. That kind of makes sense as well. If you have 10 integers, it wouldn't make sense to say, I want the 2.5 one. It can only be a whole number to access the elements of the array. So here are a few examples of arrays of different types. So suppose I want a double array, and I'm going to store rainfall values. This statement would allocate 100 doubles and initialize each one to 0.0. You could have an array of booleans. So I have 100 booleans. Each one is initialized to false, and apparently I'm going to keep in there whether it was a rainy day or not, true or false. We could have an array of objects. So this is a little bit new for you. If we declare an array of strings, we would say new string and then how many we want, and each of those is initialized to null. We're going to actually go into the development environment in a minute and look at this as we type and execute the code. But before we get there, while you're not distracted by the development environment, I want to tell you that an array has one property. It carries around how big it is. So it has a length property. When you're looping through the elements of an array, you don't use a constant in the for loop. So start at 0 and then go for as long as less than the length of the array. So an array of 10 elements, for example, has indexes 0 through 9. So that means this would be grades sub 0 gets 95, grades sub 1 gets 95, up to grades sub 9 gets 95. And the array knows how big it is. Here's another loop for outputting the values that are in the rainfall array, and we ask the rainfall array how big it is as part of this loop. Okay, during the segment on the for loop, that was a while back, we talked about something briefly called the enhanced for loop. But now finally I can tell you what it is. So the enhanced for loop in Java looks like this. We declare a local variable, and we're going to read this: for each double rain in rainfall, do something with it. So this is the for loop that says take one element out of the array and put it in this local variable, and then here's in the body of the loop, do something with that element of the array. So this is a little simpler. You don't have to keep track of the index, and each time through the loop, this local variable has the next value in it. It does the same thing. These two for loops do the same thing. So here's the old style where we had to keep track of the index and use it, and the new style where each time through the loop we just get the next one. This is for reading data out of the array only. You can't use the enhanced for loop to put something back in the array. In that case, you would have to use this old style for assigning something to the array elements. Okay, let's go and play in the development environment. So you have kind of the concepts right now of what you can do with arrays in Java, and we'll go and into Eclipse and type along with this. Get your Eclipse development environment fired up, and let's type some code that deals with arrays.
So what we're going to talk about right now is the creation and use of arrays in Java. So here's an example of what we wouldn't want to do. Suppose I was going to write a program that would add up all of your grades. I wouldn't choose to declare a variable for each student's grade. I don't know how many there would be, and if there were 100 of them, it would take a very long time to declare that many variables. So what I might want to do is to make an array or a list of grades, all having the same name. So let's look first of all at how to declare a variable that can store multiple values of the same data type. So I'm going to declare an int array. That's how you write it in Java, int array with the square brackets going with the data type. You can write it in Java with the square brackets after the name of the variable, like that, but the preferred style, that's kind of the C, C++ style. The preferred style is to put the square brackets with the data type. So we think of now we have a different data type called an int array. We don't have an array yet. We have a reference variable that could refer to an array of ints if we actually had one. So we're going to now go and allocate the memory for 10 int variables. So now we have, when line 9 executes, we have allocated enough space for 10 ints, and they are subscripted from 0 through 9. So we have the variables grades sub 0, and we could say grades sub 0 gets 99, that's a good grade, and grades sub 1 gets grades sub 0 minus 10. So anywhere you would use an int, you can now use an element of the array. And I made 10 of them here. So we would have grades sub 0 through grades sub 9. We wouldn't want to deal with each one individually. We would not be much better off than if we had declared all individual variables. So we're going to access the elements of the array using a loop. And a for loop would be a good choice for this. So let's make a for loop. Int I gets 0. I is less than grades length and I++. So each array in Java knows how many elements it has, and this is the only thing it knows. So you can say the name of the array dot length, and look at this stop condition. We want to stop where I is less than the length of the array. So the last value of I for which this condition is true is 9. So in here we would be talking about grades sub I. Let's give everybody 100. How's that? Each time through this loop, I goes from 0 to 1 to 2 to 3 up to grade sub 9. So this loop, this for loop that touches each element of the array is just very common. You should be able to do this in your sleep. We're going to go from 0 to less than the length of the array. So why don't we see if we have something that's working, and my breakpoint toggling is a little bit touchy on this machine. So I'm going to run this in the debugger, and we can watch this loop happening and make sure that we can see that we have an array of 10 int variables. So here we go into the debug perspective, and in our variables we have a variable called grades, and we can pop that open and find out that, well, we set a couple of them earlier to 99, and then we subtracted 10, and we put 89 in element 1. So we have elements 0 through 9. Notice here that elements of an array are always initialized. This is different from other languages. When you allocate space for something in Java, all of the memory is initialized. So if it's an int, the elements of the array would be initialized to 0. If it was double, 0.0, and so on. So let's step through this code and watch grade sub I. What's I? There it is down there. I is 0, so grades sub 0 gets 100. That line has not yet executed, but when I do execute it, we see that 100 goes in there, and then we go to the next I. So as we step through this, I increases and we put 100 in each element of the array. You can't do anything with all of the array elements at the same time. So if you want to do something with all of the elements of an array, you make a loop and you do it with each one at a time using the square bracket syntax to touch each of the elements. Okay, so you might be able to guess that you can have an array of any data type. I'm making an array of ints here, but you could make an array of doubles or an array of chars or an array of booleans, whatever you wanted to make. Let's have a look now at this item here. I put a constant in here, which is the value 10. It doesn't have to be a constant in Java. Suppose I had a variable kicking around, or I was going to ask the user how many they want, and the user enters the value 13. I'm not going to bother to go out and get a value from the user. You know how to do that. You can put a variable here. So memory allocation for an array is done dynamically. At runtime, we evaluate this. It must be a positive int, and that many elements are allocated when this line, now line 11, executes. So what are the restrictions on this? It can't be a negative number. You can't allocate negative 100 elements for your array. That wouldn't make sense. It can be 0. You can have an array with 0 elements in it. It can't be a floating point variable or a floating point expression. It can be only up to int, so it can be byte, short, or int, or something. That's actually an int or something promotable to int is the best way of saying it. So you can allocate as many as you need. Let's just declare a couple more arrays. Let's make an array of doubles, and I'm going to make a double array, and I'm going to call it data, and I'll say new double, and then say I want room for 100 double values. So let's fill in that array of doubles with some random values. So for I get 0, I is less than data's length, I++, and we're going to say data sub I gets math.random. So the math.random method will return each time a value in the range of 0 to 0.0 as the low value through 0.99999. So almost 1, but it will never generate 1.0. I could print those out, or I could watch it in the debugger. My preferred way is always to watch in the debugger. Okay, let's debug this. So I want to watch the array data fill up with, notice that it has 0.0 in each element, and I want to watch it fill up with random numbers generated by the math.random method. So you can see that they're all between 0 and 1. You'll never actually see 1, but up to 1. So in this example we saw an array of doubles, which was the variable was declared and we allocated the space on the same line, which of course is the same as you could do with int variables or any other variables. You can initialize them. It's just in this case we allocated the space for the entire array. Notice that the loop is exactly the same, continuing for less than the length of the array. Okay, now I want to show you a new loop in Java, and we're going to make a for loop, but this is a slightly different for loop. I'm going to say for double D colon data, and I'll do a system.out.println D. So this kind of a for loop is called a for each loop, and what we're doing is we're saying for each element in this array, get one element out and store it in the variable D. So we don't have to maintain an index. We can get each piece of data out of the array one by one and spit it out onto the screen. So we're going to, if we just run this, we're going to see each of the values in the array be spit out to the console. And there they are. Okay, the for each loop in Java was added in Java 1.5. So if this loop doesn't work on your computer, it might be because you're using an older version of the Java Developers Kit. So that's what you would want to check. This loop, you have to be careful with. It is also only for reading information out of an array. You can't use this kind of a loop for putting information into an array. So if I assign the variable D to something, that data wouldn't be going into the array. So the for each loop, which is new in Java, is only for getting information out of the array. So what I'd like us to do now is to look at how to pass an array from one method to another method. So I'm going to make a method here. That's the end of main. And let's make a method that returns a double. It's going to be static. We're going to call it from a static method, so it's going to be a static method. Static double average, and I'm going to pass in an array of doubles, and I'm just going to call it array, and I got the data type wrong, a double array. So look closely at the syntax of the parameter, and we'll declare a variable in here. I'm going to call the method find average. So we're following the rules of having a verb in the name of the array. Maybe calculate would have been a better verb. So I can now declare a variable in here, average, and return average. So inside of this method, we're going to add up the values in the array, and we're going to add up the values in the array, and then calculate the average and return that average. So what I'm really demonstrating here is how to pass an array to a method that can manipulate that array. Let's use the for I loop. We could do that with the for each loop, and our array is not called data in here, it's called array. So we're going to pass an array in, and it will be known locally inside this method as array. So sum plus gets array sub I. That will add up all of the elements in the array, and then when the loop is over and we have the sum, we can calculate the average as the sum divided by how many elements were in the array's length. So this method will work for any double array that's passed to it because we depend on the array knowing how big it is. And all arrays in Java carry around with them information about how big they are as the property length. This is not a method. That's a mistake that a lot of people will make. They'll put parentheses in here and it won't compile. So length is a property of an array. If you remember, length is a method in the string class. So the word length is used all over the place in Java, and you have to make sure that you're not using a method where you mean a property or a piece of data as opposed to a method call. Well, let's go up here and calculate the average, find average of the data. And I'll declare a local variable here called result, and put result gets find average of the data, and then print that out. What do you think the answer will be, approximately? Double quotes there. If the random method generates values between 0 and 1 and they're evenly distributed, then the average of those should be somewhere in the middle, 0.499. So right about a half, just under a half, which is what we would hope for because that random number generator doesn't generate a 1. Okay, so what we're looking at is how to pass an array into a method. You just mentioned the name of the array. No square brackets can go in here. And also how to write a method that expects an array. The data type of the parameter is a double array, and the name of the array locally inside the method can be anything you want. It doesn't have to match the name of the array being passed in. Okay, that's one-dimensional arrays, and I guess before I leave this, I want to talk about arrays of objects. It works just slightly differently than arrays of primitives. All of our examples up until now have been primitives. If I want to make an array of strings, the first thing I would do is say string array is the data type, and then I could say I'm going to keep an array of all our names. So there's the variable whose data type is string array. So names gets new string, name the data type of each element, and then say how many you want. I'm going to have an array of 4 strings. Now, I don't have 4 string objects now. I have 4 references to string objects. So names sub 0 is a variable that is a reference to a string object. And I could make the string object here. Here's Bob, names sub1. Remember that the string class is the only one where you aren't required to call the constructor to make an instance of that class. You can if you want to. So here's a string object with colon in it, names sub2 gets J, and names sub3 gets Wayne. And now we could make a for each loop for string s in names. You know, there's a conventional way of doing this for name in names. So each element in the array is one name. Let's call it name. And names is the name of the array because it has all of the names in it. Yeah, that was a little confusing, wasn't it? Well, look at the code and see how it's working. Okay, so this is going to take each element out of the array one by one and spit it onto the console. Let's run that and make sure that we're still doing something that works. And there are the elements of the array. So in summary, when you have an array of where the data type is the name of a class as opposed to the name of a primitive, then each of the, when you allocate the space, you're allocating a reference variable of that type as each element of the array. So I have 4 string references, not 4 string objects, after I do this memory allocation. Each object has to be constructed on its own, and then the array element refers to the object that we create.
And just a brief summary now of what we've looked at in this segment on arrays to try and cement some information into your brain. Java arrays know how many elements they have. They have a length property. I want you to try not to mix this up with the length method that appears frequently in Java. For example, the length of a string has parentheses after it. This is not a method call in arrays. This is a property that evaluates to an int and specifies how many elements there are in the array. The space for an array, the elements in an array, is allocated at runtime. So this is dynamic memory allocation. That allows you to determine at runtime how much space you need. The indexes of an array always start with 0. So if you declare an array of 10 elements, you can access the elements with indexes 0 through 9. It's a very common bug to try and access the array sub 10 when it isn't there, because you have to start counting with 0. Arrays can be of any data type. We can have arrays of ints or doubles or booleans or shorts or bytes. Whatever you have, you can have an array of those things. You can even have an array of arrays, and we're going to look at that in the next segment. Array elements are initialized. This is different from local variables. When you declare a local variable inside a method in Java, it's in an uninitialized state, but array elements are never in an uninitialized state. They're initialized to 0, 0.0, false, or null, depending on the data type of the array elements. Well, because the memory is allocated dynamically at runtime, you can use a variable to determine how many elements you're going to allocate. So when you create the space for the array, you could generate a random number, for example, and have an array that would be a different size each time you run it. This for loop is very important. Start at 0, continue for less than the size of the array, the length of the array, and then inside the loop you can do something with each one. And the enhanced for loop in Java for extracting from the array one element at a time and it would be a different element each time through the array. Okay, I hope you're enjoying this. The arrays are quite fun in Java, and the compiler will help you probably more than in other languages. If you make a mistake, you'll find out about it. So just jump in and start writing code that uses arrays.